Algebra 2 Honors 4.3b notes, and we are doing division with a process called synthetic division, and it's kind of limited. It's only when we're dividing by something x minus some value where the coefficient of x is 1, but it is a fun process when you can use it. And so we're just going to kind of jump right into this. And what we do is k in this instance is 2, so we're going to write that over here, and then we're going to put the coefficients of that polynomial and list them right here. So we have a -1, a 3, a 1, and you have to have every descending power in the list, and since there's no constant, the constant is 0, we need a 0 there for the constant. Then we draw a line, and we bring down that first coefficient of -1. And what we do is we take that -1 times 2 and put it underneath the next term. Then we add the 3 and the -2. And then we take that result times the 2. 2 times 1 is 2, and write it underneath the next term. And then add the 1 and the 2. And then we take that 2 times that 3 and multiply, getting a 6. We add the 0 and 6, and we get 6. And this last value, is the remainder. And these values are a polynomial of 1 degree less. It's the coefficients of that polynomial. So this is a minus x squared plus x plus 3, the polynomial 1 degree less. And then the 6 is the remainder, so we write it as 6 over the divisor of x minus 2. And there we've done the division. All right, so in example 2, we're dividing by x minus 1, so k is 1, so I'm going to use a 1 here. I'm going to have the coefficients. I have a 3, a -7, a 6, and an 8, and I've got every power represented, 3, 2, 1, and then the constant, so that's good. So draw the line, bring down the 3, and now we start to multiply. So we take 1 times 3 and write that product underneath the next term. And then we add the -7 and 3, and take that times the 1. 1 times a -4 is a -4. And put that under the 6. Then we add the 6 and the -4, getting 2. And then we take that 2 times the 1 and write it underneath the next term. And then add, and that last one is the remainder. And so the 3, -4, 2 are the coefficients of a polynomial of 1 degree less. So we have a 3x squared minus 4x plus 2. And 10 is the remainder, and we write that over what we were dividing by and add that. Okay, I have a U try, but I want to talk about the setup for this. This is x plus 3, which we can write as x minus a -3. So k is a -3 in this case, so we would put a -3 out here. And for the polynomial, we need to have every descending power have a placeholder there. So we have a 2x cubed, but there's no x squared term, so we need a 0. This will not work if you don't do that. And then we have the -1 and the -7. So now you can pause the video and go ahead and do that division and see how you do. See how you did. Bring down the 2, multiply times -3 is a -6. Add, take the -6 times -3 and add, and take the -3 times 17 and add, and that's the remainder. So we have a 2x squared minus 6x plus 17 plus a -58 over our divisor of x plus 3. How'd you do? All right, now we have the remainder theorem. And if a polynomial is divided by this x minus k, then the remainder can be found by plugging that k value into the function. And so use synthetic division to find the indicated value. So when it says use synthetic division, you have to have the synthetic division. What we ultimately want to get is f of negative 2, but we're going to use synthetic division. It actually is a nice way to do it. And so this means if I want, when x is negative 2, that was x plus 2 equals 0 was the factor, or what we're dividing by is x plus 2. So the k value is a negative 2 for synthetic division, though. Have all the descending powers recognized and in the list, but we had cubic, so we have the cube, the squared to the first, and the constant, so we've got them all there. And then bring down the 4 and multiply times negative 2, and add and multiply by the negative 2, and add and multiply by the negative 2, and we get a negative 19. And that remainder is what you would get if you put negative 2 directly into the polynomial. And I think actually doing that synthetic division is better than if you just plug it in. So, I mean, literally, if you put in that negative 2 into this function, you would get out a negative 19. So it also means that if I am, graphing this, when I put in that negative 2, the output is negative 19. So it is the distance that point is from the x-axis. So some connections to make that way. But when they say use synthetic division to evaluate, you have to show this process and then you state your answer. F of negative 2 is negative 19. So you can you try it. And so pause the video and you check it out, see how it goes, see if you do the division right. Okay, see how you did. Did you remember 0 for the squared term? If you didn't, it's just something you have to remember with synthetic division or it will not work. Bring down the 5, multiply by 2, and add, multiply by 2, and add, multiply by 2, and add, and multiply by 2, and you get 50. And so what that means is f of 2 is 50. And I'd rather do it that way than take 2 to the 4th times 5 and 2 cubed times 2 and do all that in adding. The synthetic division is kind of fun to find the remainder. So that's the remainder there. All right, so then we have a couple of applications. So you need to read the word problems. They aren't actually necessarily all that challenging, but you have to kind of interpret them and apply it to this synthetic division. So the profit in millions of dollars for a DVD manufacturer can be modeled by P equals a negative 4x cubed plus 32x, where x is the number in millions of DVDs produced. Use synthetic division to show that the company yields a profit of 28 million when 1 million DVDs are produced. So we've got profit is this minus 4x cubed plus 32x. And basically, I want to evaluate this when x is 1. So I want to find P of 1. And we're going to do synthetic division. So that means that my divisor is really x minus 1, but we're going to use 1 in the synthetic division. Now, be careful, you need every descending power recognized. So we've got a cubic, and we've got the coefficient of x cubed is negative 4. The coefficient of x squared is 0. The coefficient of x is 32, but the constant is 0. So you need both of those zeros in there. Bring down the negative 4, multiply times 1. Then add those, multiply by 1, and then add, multiply by 1, and add. And that remainder is 28, which means P of 1 is 28. So use that, which is for 1 million DVDs, the profit is 28 million. So we've shown that using synthetic. But is there an easier way? Well, you could just evaluate. P of 1 is a minus 4 times 1 cubed plus 32 times 1. And that, since it's 1, you might argue that that would be easier to just directly substitute, just because the 1 is easy to cube and multiply by 32. All right, so now I want you to apply synthetic division in this, because that's the section, this next problem. What is the value of k so that this has a remainder of 0? Well, I'm going to do synthetic division with a variable. This x plus 4 can be thought of as x minus a minus 4. So my k value is a negative 4. And so I'm going to do synthetic division even though this has a variable in it. The coefficients are 1, and the coefficient of x squared is k, so I'm just going to work with that variable. And then minus 9 and minus 36. And so here we go. Bring down the 1, multiply by negative 4. Now the trick here is k plus a negative 4 is just k minus 4, and we're going to work with that binomial, that expression. It's a little abstract. And I'm going to take that k minus 4 times a minus 4, getting a minus 4k plus 16. And that goes underneath this next term. And when I add those, the minus 9 and 16 are like terms. So I get a minus 4k plus 7. And then I'm going to take that minus 4k plus 7 times a minus 4, which is a 16k minus 28. And when I add those, that's going to be my remainder, and I get 16k, and 36 and a minus 20, minus 36 minus 28 is a minus 64. And remember, so that it has a remainder of 0, this is my remainder, and I want that to be 0. So now set up an equation. I want 16k minus 64 to equal 0, and solve for k. And you get k is 4. So that is using and applying the synthetic division and the remainder theorem. All right, example 6. Find the volume, or they tell you the volume of this is this. Find an expression for the missing dimension, which is right here. And volume is length times width times height. So this 2x cubed plus 19x squared plus 54x plus 45 must equal, well, we don't know what this is. So this factor that I don't know times x plus 5 times x plus 3. So to find this unknown factor, I think I wrote too big because we're going to have to do longhand division. You're going to multiply these out, which is x squared plus 3x plus 5x plus 15. So this unknown factor times x squared plus 8x plus 15. And so maybe I could go back and let this be my length, and then I have a variable in here that I'm solving for instead of a question mark. And so that length is going to be what I get when I take 2x cubed plus 19x squared plus 54x plus 45 and divide it by x squared plus 8x plus 15. Now, that x squared plus 8x plus 15, remember that came from that factored form of x plus 5 plus x plus 3. So there's actually going to be a little faster way to do this. I'm going to go back and leave it factored. But it's because each of these factors, sorry, I didn't leave myself enough room, because each of these factors of that form x plus 5, x plus 3. And so what I'm going to do is I am going to divide synthetically using a -5, using the 2, the 19, the 54, and the 45. And bring down the 2, multiply by -5 is -10, add is 9, times -5 is -45, and add is 9, and times -5 is -45. And I expect it to go into there with a remainder of 0. And then the 2, the 9, and the 9 are a reduced polynomial, and I still haven't divided by the x plus 3. So I'm just going to use a -3 and do synthetic division again. Bring down the 2 times -3 is a -6, and add is 3 times -3 is -9. I expect that to be 0. And so I've reduced the degree twice. It was cubic, so I got down to squared. And so the 2 and the 3 represent 2x plus 3, and that is my missing dimension, 2x plus 3. Kind of fun. Example 7. When you divide two polynomials and this is the result, what was the dividend? And remember, you've got your divisor. The dividend is what goes underneath. And then as you solve, you get your remainder. And up here is the quotient. And so we had this, if you take a polynomial and you divide it by something, it becomes the quotient plus the remainder over the divisor. And so it is this that we are trying to find. That's what we're trying to find. That is your dividend. This is your dividend. It was what goes underneath the division sign. So if I multiply both sides by d of x, then I can solve for that dividend, and I have to distribute the d of x to each of these, and I get q of x times that d of x, and when I take it times the fraction, the d of x's cancel, and I just have this remainder. And so that's what I want to do. I want to take the quotient times the divisor and add the remainder. So how is that related to x squared minus 3 plus 6? Well, if I think about this structure, the x plus 1 was the divisor. When I got done, I had a 6 for my remainder, and the quotient was the x squared minus 3. So to find the dividend, I need to take that quotient, multiply it by the divisor, and add the remainder. And so now you just need to do the multiplication and my f of x is x cubed plus x squared minus 6x plus 6. And that was the dividend. So you multiply the quotient times the divisor and add the remainder. And I think I've got that okay. X squared, x cubed, squared minus 3x. Yep, okay. Just wanted to double check. And then number 38 has to do with the remainder theorem, and I kind of hinted at it that the remainder is the distance from the x-axis. And so when we have this f of x divided by x minus k has a remainder of -15. The remainder is the distance from the x-axis when we talk about graphing. Which technically just means it's the y value. So this is really saying, when y is negative 15, what is the x value? And right here is negative 15. So that is this point. So what is the x value? It is negative 4. So f of a negative 4 is negative 15. And so when x is negative 4, you get a result of negative 15. So what is the value of k? It is negative 4. And so now you can use that to help you with b. Use the graph to compare the remainders of these two. And you just have to remember that if you're using x plus 3, the remainder is f of negative 3. And if you're dividing by x plus 1, the remainder is f of negative 1. So you can compare those and talk about that when you do number 38. That's it.